Oh no! Hello, ladies and gentlemen. How are we doing today? Admittedly, I have been live streaming for 8 minutes, or at least I thought I did. I forgot to press go. I have to press go twice, and I only pressed it once, and I forgot. So that's really, really funny. But now we're here together. Hi, Susan. And we are looking at a burying beetle here today. Yeah, it's Halloween colored number 1, which makes it a great kind of insect to talk about near Halloween. But also, they make a crypt that that their babies eat dead animals in. I mean, it gets really crazy. They also will fight each other a little bit, so we're going to talk about all of that stuff. You are right, they do have fancy, fantabulous tibial spines. I love that you're looking at the shape of those already down there. Also, the tarsal segments on burying beetles are very, I want to say like serrate. They're very like sharp. They also have, each one of their tarsal segments have these like spines that come off of the corners. It's really kind of cool. So burying beetles, like this beetle here, are in the genus Nicrophorus. Now, I'm not sure exactly what species this one is, so that's why I wrote SP on my paper. You write 1P when you know it's just one species and it's not like a group of multiple species. If it's a group, you put 2 P's here, SPP. This is in that genus Nicrophorus. And actually, Nicrophorus is where you are going to find all of the burying beetles. Now, if you wanted to kind of follow some taxonomy here, there was some weird stuff that has happened with the taxonomy of these beetles in the last couple of years. And so if you were out and about looking for information, they might be listed under 2 different family names. So I want to share that with you. And Susan in the chat says, necro with an E would be death. Is nicro different? And what's really funny is that sometimes people do spell it Necrophorus rather than Nicrophorus. But the issue is that Fabricius is the individual who named and defined the genus Nicrophorus, and so valid under all of the rules and things. He spelled it with an I back in like the 1700s, and so now people want to spell it with an E, and some people have and will, but it's not the official name, funny enough. Fabricius. He's like Fabricius is a really, really famous entomologist who was he was a really famous entomologist in like the mid 1700s and spent a lot of time in systematics. So he described a whole lot of genera that we know. And he was like the first person to describe a whole bunch of genera. Fabricius. And he spelled it Nicro, so I guess that's how we spell it. Anyway, so burying beetles here are in this genus Nicrophorus. If we follow them back up, but in a context where he would have probably been an ancient Roman. Interesting. Well, this is Johann Christian Fabricius. He studied, I just looked him up really quick because I wanted to remember. He studied under Linnaeus. And Linnaeus, you know, was the guy who created our naming system. Our two-word naming system. There were other naming systems already in place, but he just decided that he was going to create a new system, and everyone from then on had to just follow the new system. And then Fabricius was one of his students who was very... he spent a lot of time identifying and writing up papers on new species. Anyway, that's a little bit about old-timey entomologists. Also, I'm guessing that's a Latinized name like Linnaeus. Yes. I would assume so. But I'm not sure, Susan. So if we follow burying beetles up the taxonomic tree, you will find Nicrophorus the genus in Nicrophorinae, which is a tribe. Now the tribe isn't a whole. There are a couple of different tribes, but what's interesting is the subfamily that they exist in, which is Sylphinae. All right, so they're in this subfamily Sylphinae, and in the subfamily Sylphinae, you have both the burying beetles and the carrion beetles. And back when I was learning entomology and I was doing the family names and stuff, the sylphids, the burying beetles and the carrion beetles, were their own family. And when you have a name that's in family in an insect world, it has an IDAE in the end of it. So this is how you would see it over and over and over again. And this is what's going to be most commonly found in texts. But this is now changed in the last 2 or 3 years. They took this whole family. There was some new genetics that was done on beetles and beetle families and how they're related to one another. And this whole family of burying beetles and carrying beetles became a subfamily. So we changed that D to an N. That's how subfamilies work in the insect world, is they all end in an INAE. And now they are a subfamily within rove beetles. When they did the taxonomic tree and they created the family tree of all of the beetles and the beetle families, burying beetles came out right smack dab in the middle of the rove beetles. So now we know that burying beetles are actually a kind of rove beetle. And wow, it was that recent. Yeah, this happened within the last just 2 years. I would actually be, I wonder if, I do kind of wonder if it would be a quick one for me to find. Because it would be such a recent publication that if you sort it by date, nope, they don't have it in here. Okay, that's fine. So anyway, they are a rove beetle, but we are just going to use their common name, burying beetle. All right. I already had some fabulous observations from Susan in the chat about the tibial spines, and about the tibial spines that we were seeing, and then the spines on the tarsi, the black and orange colors. I want to kind of rotate the specimen a little bit, give you a view of it before we pick an angle to draw, because for me, I do like to see this beetle from a lateral perspective, but I like this drawing better dorsally because I think that it shows the elytra better, and I love that the elytra are shorter than the abdomen. So I want to kind of give you a tour of the beetle, and then you can check out the angles and let me know what you think you would like to draw today. The other kind of crazy thing that we could do is I could draw really kind of a small basic version of the beetle here, and we could just draw parts of it. Like, let's draw a front leg, or let's draw just a really close image of the head from our favorite view. I don't know. It could be fun. All right. So we already have seen it from this angle. Let's go ahead and look at our beetle head on. He's got nice big eyes. Oh, look how cute. Cool. You've got a frontoclipial suture that's really visible. We could dive into those characteristics if we would like. So that's our head. I love that they have absolutely ginormous eyes, and their cute little palps are sitting there. The antennae are kind of pushed back. But if I turn the specimen kind of sideways like this and we look at it just like that, we can see the antenna. And this is what we would call a club. It is a symmetric, this is a symmetric club. So if you look at the center of that antenna, the club expands evenly off of both sides of the center line. But what's cool about it is this antennal type in the beetle keys is considered lamellate. And lamellate antennae have the ability to kind of open and close. So I guess if you see like the flanges on the sides of this club here, there's enough of, like, I guess, wiggle room. Yeah, the antenna here are really fun. Let's see. It's in 6th edition of the Born to Long book. There's a really cool image in the Born to Long book of beetle antenna. And there is an actual kind of line drawing of this exact antennal type in this book. And so that is why I wanted to show you. Okay. Check this out. So, this is oh yeah, sorry about all this craziness. I haven't added a background yet. But, this is what we're looking at anyway. Here. Haha. Okay. So, we've got all different kinds of antenna here, and these are all antenna that this book considers clubbed antenna. So they use the term clubbed as almost like an umbrella term to describe any antenna that are kind of expanded at the end. In fact, a lot of the ones above here are clubbed too. These ones here. These ones are not. All right, but these guys and these are all considered clubs. Now, all of these ones down here I lied to you when I said they were symmetric because they look so symmetric to me in the underneath the microscope, but technically they are an asymmetric club. So if you see how, and we're gonna have to double check. We're gonna have to look back at this on the underneath the microscope to see if we can see that the club here, and see it's the same genus, Nicrophorus. Sylphidae, the old family name. We can see that the club is kind of asymmetrical here, because then a lamelate antenna is one that has the ability to open and close. So you'll recognize these ones from different types of beetles. You might recognize this one from, we drew a best beetle at one point. That's a best beetle antenna. But yeah. That's cool. All right. So we're going to have to turn this because I think that we're just looking at it 90 degrees in the wrong angle. All right, I think I missed a couple of questions in the chat because I was getting distracted by antenna types and pretty pictures. So let's see. Do you think Linnaeus, when he created his new taxonomic system, anticipated that we would still be rearranging things hundreds of years later? I think that he purposely built the system so that we could. There was a naming system in place at the time, but I think what he was noticing and realizing is that the system in place at the time was not going to be able to expand and grow in a way that allowed for like the diversity of life that was out there, because when they first started they had no idea what they were diving into as taxonomists or biologists or botanists or zoologists out there in the 1700s. And so I would argue, for me, like looking back, I would think that Linnaeus did purposely build the system in a way that he knew it would be able to expand and continue to be used hundreds of years later. I don't know if he knew we were going to be kind of like bickering back and forth about who's a subfamily and who's a family so aggressively, because sometimes research articles and things will get kind of aggressive about like going back and forth about which one's correct, and whoever is the most recent one to publish is the correct one. So it sometimes is a wild ride. Yeah, so an interesting thing about the system and the rules of the system is the first genus that is described, the first genus that's described follows all of the steps up. So I'll use Nicrophorus as an example. Nicrophorus is the genus. Now, if you take one step up, the tribe, all tribes end in INI. So the tribe of Nicrophorus is actually Nicrophorini, because Nicrophorus was the first genus described in this tribe. But there are multiple genera in this tribe already. Okay? And then you get Sylphini and Sylphidae used to both be a thing. But Staphylinidae wins because the rove beetle was identified before, the rove beetle was first identified before a carrion beetle. And so that's why you don't hold Sylphidae and make Staphylinidae and make rove beetles the subfamily. So there is a reason why they choose which one is above the other ones, and it's based on who was published and identified like officially first. So on our beetle, the attachment point is at one edge of each segment. Yes, exactly. So on this beetle here, the attachment point is going to be on an edge, and it gives the antenna the ability to kind of open and close a little bit. So let me see if I can get at that angle so we can see that, because that was one that wanted to be able to show you. I mean, think that that's gonna be your best angle for the antenna there. And I'll scooch it just over a little bit so it's centered. Okay, that's going to be your best view for the antenna there, and you can see that where the smaller segments go up to meet the actual physical club, there it's expanded further to the left than to the right, and those are actually, they're all connected along the right side. So if you follow that line, the club is asymmetric, it's off-center. Life is good. We are looking at a burying beetle tonight. It's a good naming system because you can actually keep the species name. Yeah, exactly. All right, fabulous. So, that is a little bit about our antenna. Let's go ahead and I wanted to look at this beetle also from a dorsal perspective. I know we've been talking a lot about him. We still have to go over life cycles and stuff. I just want to show you him from all angles and then we'll draw. So, the burying beetle from above, you can see that we've got actually a pretty large scutellum, that big triangular piece in between the wings, in between the front wings here. And then you have this really beautiful orange banding. Now the black and orange banding is common on burying beetles. And then if I kind of rotate this burying beetle forward, we can see all of the abdominal segments after the elytra. And look, it's got mites! How cute are those? They're hiding under its elytra. Those are called commensalistic mites. Some people have and may argue that they are actually mutualistic, but I don't know how much evidence they have for that. So commensalistic for sure. The mites are literally just hopping a ride on the beetles so that they can move around faster. Plus, the beetles are really good at smelling death. They're burying beetles. So when the beetles get to the death, the mites can pop off, and the burying beetles are quite literally bringing the mites to their food source. So there's that. Some people have argued that the mites might help the digestion of the food for the larvae, like the what the mites do when they're feeding on it, and that's why I don't know. I haven't read an article that says yes, they're for sure mutualistic. But the thing is, if you're out collecting bugs and you're out seeing burying beetles, you're gonna find a burying beetle that is absolutely covered in mites. Like a pile of mites on top of this burying beetle. It'll have hundreds of them on there. And it still doesn't really negatively affect the beetles at all. I've definitely seen my fair share of really, absolutely burying beetles that are absolutely piled in mites. So many so that you can't really see the beetle underneath it, but you know it's a burying beetle because of the number of mites that are on it. Generally, they don't have all of those hundreds of mites don't stay on the specimen after the specimen passes, but sometimes you get a couple of them that'll stick around. All right. I'm thinking because of the angles that the head is kind of curled down and the abdomen is kind of curled down, I think that it just makes more sense to draw this beetle as it is from a lateral perspective, so that we can draw this kind of true curled up shape here. It'll be a fun one. I think it'll be fun. We got this. So, burying beetles. Let's get drawing. And while I'm drawing this nice light sketch, I'll talk to you about how they find their mates. All right. And we'll all have a good laugh about it together. Susan says we haven't gotten a good full view yet. This is right about as close as we're going to be able to get to a full view underneath the microscope. But what I can also do, let me see. Doop. What I can do is show you the beetle this way too. The specimen all curled up is about 3/4 of an inch, but I would argue it's probably 7/8 when it's stretched out. So almost an inch. Okay. Alright, so this is going to be kind of our overview image of this beetle here. I'm going to just make it so we can just barely see that front of the head, and then I'll scooch it over once we're all done with that. I want you to kind of imagine also one of the things that I see when I'm drawing is I'll look at the lateral line. So I'll look at where the top segments of the abdomen of the body are kind of meeting the bottom segments. In that way, we've got the elytra here. A lot of times is going to follow the edge of that line. So you've got this. And then right here, this is the pronotum. And this line that starts here and kind of angles this way, that's actually what I would consider the lateral line. That's the side between where the top of the exoskeleton is meeting the bottom. So this is going to go across this way, and then it angles really sharply kind of down this way. Just so that I can vocalize some of the things that I see while we draw. Do you know if Nicrophorus was considered a sylphus or staphylinid before the split? Bags. The burying beetle Nicrophorus was considered a sylphidy, up until just a couple of years ago, and then it became a staphylinid. Oh, with that silhouette, it was probably considered a sylphid. Yep. Ooh, could we maybe zoom on the mites if we have a moment? I wonder if they're Europodoidea. Ooh, I don't know. I guess we could look at them. I will admit to not knowing a whole lot about mite families, but what I can do is get you a decent image of one so that you can let us know. I have to get this sorted first. I have to overexpose it. Okay. Let's see if I can get this mite any clearer. Oh boy. It's kind of cute. You can see its little eye here. Like that little dark spot. It's kind of cute. So there's that one, and then there's another one over here. And it almost looks like that these two are almost, maybe they're two different life stages, because, or maybe this one's fed more. It just looks more plump. See if I can get it to the right spot. All right. Well, that's the other mite. Broad question. I read somewhere that burying beetles are one of the few insects that care for their young. How true is this? Also, I remember that when begging, the larvae might be eaten if they beg too much. Oh my goodness. Yes, life is good. We are going to talk about all of this. We need to talk about the life cycle, and we need to talk about their how they choose mates and all of it. So let me go ahead. We're going to restart this camera. I'm going to start drawing, and we can talk life cycle and mating dances, because 100% you are correct that burying beetles are going to care for their young. They both the mom and the dad, the male and the female, will do parental care, which is really cool and not super common in beetles. My camera has decided to be wildly yellow, so I'm gonna have to rebalance this quickly. All right. That didn't work. White balance. Once. Exposure. Oh, I see what's happening. Now it's fixed. Okay. Sorry, ladies and gentlemen, I had some wonky things happening with the gain and the exposure. All right, let's get some overall shapes accomplished and talk about burying beetle mating. See, burying beetles can smell death from a significant distance away, right? And so when something dies, that thing is going to be putting off a scent that might smell appetizing to some animals, and to the burying beetles, they're like, absolutely yes. Not only am I going to go there and find a dead animal, but also I'm going to go and find myself a mate. So they're going to arrive at maybe a dead mouse or a dead bird or something. If the dead animal is pretty small, like a mouse or a bird, those burying beetles, there's not going to be enough food for everybody. So what they do is they have little fights to determine who's best and who deserves to have this opportunity. So what happens is all of these burying beetles come to this dead animal, and then they separate themselves, and all of the boys fight one another, and they find like the top boy, and then all of the girls fight each other too, and they come up with the top lady, and then the top dude and the top lady, the two burying beetles that have like out-competed everybody else, they're gonna mate. All right, and that's how they choose their mate, and I love that for them. It almost feels like a mini Hunger Games type of situation, like a little mini competition. And so that's how they're gonna find a mate. But then not only do they then mate, and they have to now start prepping the dead animal for their babies. And what they will do with their cute little mandibles, all right, with their cute little mandibles, these burying beetles are going to be individually plucking hair off of mice, or clumps of hair off of mice. They'll pluck the feathers off of the birds, all right? So they're actively kind of working this dead animal, kind of plucking and pruning and doing all of these things. And then they're going to, and in that process, they're also going to be burying it. So, once they've got it all situated, what they have done is they have buried this animal. They've plucked all of the hair and all of the feathers off of the dead animal. They have kind of preemptively chewed up and spat out a lot of the meat, because they have antibacterial and antimicrobial saliva. So when they chew up the meat and spit it back out, they are actively kind of preparing the meat to make sure that the dead animal that their babies are going to be eating, the meat doesn't like expire, the meat doesn't go bad. And so they essentially go underground and they make what is called a crypt. All right, which is like an open space underground. And they put their meatball in the center. Now it's the male's job at that moment to actively protect and defend the meatball. All right, this is flesh. The other thing is that their saliva with the antimicrobial and anti stuff, it's also going to make the meatball smell less, so that it doesn't attract as many insects from as far away. But it's still going to be smelled by ants, and it's still going to be smelled by flies, like bottle flies and things. And when other animals do approach the meatball, the male is going to like scare and or fight them away. So if ants do ever approach it, they are going to they get just kind of ran off by the adults. And while the male is there doing his due diligence and protecting the meatball, the female burying beetle is going to leave the crypt. She's going to kind of crawl out of the crypt. She's going to dig her way into the substrate around the crypt. And she is going to lay her eggs. And keep in mind, these eggs don't get laid, they don't get laid inside of the crypt, they get laid outside of the crypt. And then, when she gets done laying all of her eggs, she is going to nicely go back to the crypt and help protect the meatball with the male burying beetle. Alright? And they will both patiently wait for their babies to hatch and for the grubs to come to the colony, or for the grubs to come to the meatball. Susan, when they bury it, they dig the dirt out from underneath it. And that is what puts the dirt above it, and that's how they're going to bury it. And they'll go like feet underground. Susan also has the question, why don't the burying beetles eat the hair and the feathers, because they do have some protein in them. I think that you need specialized digestion to eat those types of things, and I don't think the burying beetles have that. Alright, let's see. Where were we in the story? Because I was drawing, but where were we in the story? Oh, yes. The eggs are going to hatch. And when those eggs hatch, the grubs, the burying beetle grubs, are going to smell the lovely meatball, and they're going to get all excited, and they're going to crawl their way into the crypt, and then they're going to see this fabulous meatball, and they do have chewing mouth parts, and they have the ability to chew from the meatball that is technically already pre-chewed by their parents anyway. And they're going to nom on this meatball. Now, there is some begging that occurs. They will kind of chirp or squeak. They kind of will make sounds to one another. And if they do, the adult beetles will mouth feed their babies, even though they don't have to. Even though it's not like a required part of their lives, the adults will. Now, the a lot of adult insects who feed their young are also transferring gut microsymbionts from adult to young. When they're chewing and like mixing up with their spit and their saliva and they're holding it in their crop, you're actually also sharing a generational microsymbiont that has been helping to digest food for generations, right? So that it should already be in the meatball, but it could be beneficial to also have food directly from mom and dad, which is probably why that behavior hasn't been adaptively chosen to go away. Anyway, so there's that. Now, was it Bags who asked? No, I think it was Life Was Good. Life was good. I hope that you are still here and hanging out for this story. So they have incredible care for their young, both the males and the females. But you also said that when the larvae begged too much, they might be eaten. The larvae can get eaten by the adults, but it is not, it's not because they're begging too much. Burying beetles are one of the very, very few insects out there that will commit infanticide. They will kill their own young on purpose. And that's because if the female has laid, she'll just go out and she'll lay as many eggs as possible. If too many of the larvae start coming into the crypt and the adults realize that there's not going to be enough food for everybody, if there's not going to be enough food for all of the larvae, then the adults will start to kill the young so that there's going to be enough food for all of them to survive. Burying beetles. And how perfect is it that like they're already in a crypt? Can we say that? Alright, so right here, now all we have to do is make this a kind of elongated abdomen that is angled in this downward, like downward position. Also, I have right here is the edge of the elytra, but we still need kind of the bottom of the thorax here, and it does kind of like, it lines up a little bit like this. So we've got right about to the halfway point of there. I was trying to see where the thorax ended. So right about there is where the thorax is going to end. You can see that the thorax essentially ends where you can see that hind leg come out. After that point, you are looking at abdomen, and the abdomen is what has those kind of really cool ventral spines on it, and also is nicely kind of curved down. That's actually not horrible. Cool. All right, so that's where I think I'm gonna be starting with my beetle illustration. There's a good chance that the abdomen is going to kind of come up a little bit. A lot of times the thorax is a little bit boxier because of the muscles, and this is where this coxa is going to be anyway. Something like that, maybe even lower, but okay. Alright, I think I'm pretty happy with that shape so far. So we are going to zoom in to the head here and get some of our final details sorted. So this is going to be my kind of light outline of the specimen before we really start to add some details. Things like, man, look at that compound eye and how much space it takes up of this head. Okay. So yeah, burying beetles are the perfect Halloween, have the perfect Halloween life cycle. So I'm going to turn my paper a little bit so it's easier for me to see and sketch, but the back of the compound eye here seems to be kind of straight across. And that's because from the top of the head is kind of like, if I was going to draw the top of this beetle's head, it would have this approximate shape, and then the back of the compound eye doesn't start here. It actually has that little bit of a ledge. So that is what it looks like from the top. But when you're looking at this, when you're looking at it from a side view, you're just going to have kind of this straight line and almost like a D-shaped compound eye. Right around here. It also looks that the back of it is like completes a perfect circle, which is cool. I like it. I'm going to make the antenna go forward rather than backward. Alright, what I'm going to do, because I'm really enjoying the fact that the back of the compound eye seems to be a perfect circle with the front, and that it touches the back edge of the head here. So that seems to me like an easier shape to draw. I'm going to very lightly get myself a nice kind of big circle that has its edge right at the edge of the, right at the edge of the head here. And then I'm just going to cut off the back of it, kind of like this, and then follow that shape. Love it. might even leave a little bit of shading back there so you can see the continuation of that circle. Now, the top of the head is not as smooth as I originally sketched it, so there is a little bit of a ledge here. And it looks like where the head is connected to the pronotum, the head's going to kind of tuck into the pronotum. It's on it almost like an angle here. That's why I'm, so what I'm seeing is the head. I have it here. I have it here, but I need it to be more like here. Needs to be a stronger angle here, because then I've got the top portion of the head that comes down and is kind of round up until the back of the compound eye, and then it's smooth across the front, just like that. And then once it gets down to here, that's when we're worrying about mandibles and things. I do need it to come down a little bit sooner. Okay. And then straight across, because that's going to be the end of the head and where the mandibles are going to be. And then I'm actually pretty happy with the bottom side of my head here. I do want it to come out just a little bit, but I think that is mostly a shadow in the background. So you see how there's that extra little spine there, but I don't think that spine is this front edge. I think that it's kind of like a piece down underneath the head, so I'm going to shade it in a little bit. And then the bottom of the head follows the circle. Cool. I'll go ahead and drop some cross hatching within the compound eye so that there's lots of little individual lenses within it. All right. And now we get to sketch these antennae. Now, here is something funny, because sometimes books will do this to you, and they just like to continue to add words for these antennae. Now, we already know that it is an asymmetrical club, right? A lamellet club that opens and closes. But the other characteristic that you might notice about this antenna is if you are looking at individual segments, right? Scape, the first segment, pedicel, the second segment, and the flagellomeres are the rest of them. Now, the scape is super long. And when you have a really long scape like that, we call them an elbowed antenna, because you can see right after that really long scape, all of those segments after are kind of short, and they bend at like an elbow, a bend at a 90-degree angle. So we also would consider this an elbowed antenna. To add bonus words to the bonus words. You're welcome. Life is good. I'm glad that you dropped by. All right. So the scape, nice long segment here, connected, kind of right in front of the compound eye. I'm going to make the antenna move forward. They do have a place where they'll kind of like almost tuck their antenna backward, but they do actively use them too, and so I want to make my beetle with its antenna out. You got that one nice long segment there. Then there is 1, 2, 3, 4, 5 smaller kind of triangular or smaller globular segments. The pedicel is a triangle for sure. Narrow at the base, wider at the end. But the rest of them are varied. And I made the pedicel even too small. I need to make it a little bit bigger than that. I need to make it so that it exists. There we go. So that's the pedicel. And then the flagellum ears. Let's see. 1, 2, 3, 4. Kind of roundy. 1, 2, 3, 4. Alright. So I'm at a total of 1, 2, 6. And now we're at this club here. And I see 4 segments of this club. But I do believe that this is a 5-segmented club. So let me see if we can zoom in and see the other segment. I think that there's an additional segment in that end tip area. If I add some exposure time without, yeah. So on this antenna here, the club has 1, 2, 3, and then this one is actually 2 segments. It's hard to see the line, but it goes from here and it kind of views down and it goes back up this way. So this is actually 2 segments here at the end. So these beetles do have 11 segmented antennae, because even though they have different names, the scape, the pedicel, and the flagellum ears, they're all still considered antennal segments. So for wordy times, you could say that they have 11 antennomeres. Pencil. I have to rotate this in my head. This is what it looks like kind of backward. And I'm just taking this antenna and pulling it forward. So the phalanges would be towards the inside. But because we're drawing it laterally, it's going to look symmetrical because we're drawing it 90 degrees from the angle that it looks. That's fine. We're going to do it this way. 5 segments. 1, 2, 3, 4, 5. Alright, so that is our 11 segmented antenna. Now for drawing and looking at the mandibles here, when I'm just looking at it from a perfectly kind of lateral perspective, yeah, see, the mandibles just look nice, long, and thin. Right about there. So, just coming off of here. They just look like they've got nice long thin mandibles. And then coming off of the bottom, I do see at least one of the palps. So I'm going to give myself a little 3-segmented palp here that runs along the base of the mandibles. And that is going to give me the head of this burying beetle. You could shade in everything but the orange tips of the antenna if you were interested in getting kind of the black and orange on your burying beetle all illustrated out. Okay. Pronotum. One of the things I love about the pronotum of burying beetles is the edges of the pronotum are so distinct. And you can see they kind of like go over top of the elytra a little bit. It gives them that ability to kind of curl down. They also, the head kind of fits into the pronotum. I don't know. There's something fun about the edges and how solid it feels. I'm actually pretty happy with my shape here so far. I do want to just make sure that it lines up a little bit better with my head now that I've changed the shape of the head a little bit. So when I follow this up, I'm just going to not go out as far, but I'm still going to come up. Angle down I'm happy with, so we're going to go ahead and do that. Once we get to the very top, instead of it just being kind of one point and coming back, I'm gonna go up to that point, but then because there is a little bit of distance kind of happening here, I'm gonna give myself kind of an angled line this way. Kind of like it's a flange that's going up, and then we're gonna follow this U back around. Cute. That is what we would call the pronotum because it is the first segment of the thorax, but it is also on the top. So pro comes from the first segment of the thorax and notum comes from the top. On the underside here, this would be the prosternum. So the bottom segments. Now, we've got some interesting lines happening here, and I just want to tell you, the thorax is normally very boxy. The shape of the prothorax tends to be highly variant. So this is what we need to imagine. We need this thorax to kind of come across, and we need to imagine that the end of this elytra right here comes kind of straight down. So that's where our thorax is. And then for the prothorax, it's got to kind of fit that narrative. So make sure that when it curves down, that thorax is still box. And that's what I'm seeing here while we're looking at it. The reason why I noticed it when we got so close is because I'm looking at where the legs connect. So right here, this piece is that coxa, that's that hip bone of the front leg. And it is going to connect to the prosternum right about here. So I'm imagining this as kind of a smaller loop than what I had originally had. Plus, look how close the middle leg connects, right? So it's right up there in the front. And you know what? The legs are connected at the ends of the segment. So the second segment of the thorax is not very large. But the third segment is, because we'll see that there is a little bit of a space in between where the second leg comes out, where the third leg comes out. All right. So this gives us this overall kind of nice light U shape in here. I kind of wonder if that's a notopleural suture, and I need to know, so I'm gonna... It is not. Okay. Look how cool the antenna looks like from below. Huh. Alright. Alright, so now I'm trying to decide where exactly we're focusing on next, and what I think I would like to do is draw this beetle from the front to the back. So we're going to draw the leg, the front leg next. That's going to give a lot more clarity on what exactly we're doing with the middle leg too, and the middle leg interacts with the elytra, so I think that it makes sense to do the legs. You know, rove beetles have parental care too. A lot of times it's only the adult females that care for the young in rove beetles, I believe. But because the burying beetle is now a kind of rove beetle, it's interesting that they do share some behaviors. All right. One of the things that I can see right away is this coxa here. So let me go ahead and I'm going to give you all the leg words. I may have just lied. I'm going to give you all the leg words but trochanter. I don't think we'll need that one today. Okay. So the coxa, you'll hear me say that. That's the hip bone. That's going to be the closest segment on the body. And sometimes it looks like it's a part of the leg. Sometimes it's actually actively fused into the body. But I like to imagine the coxa is essentially like the hip joint. A lot of times it can move in kind of two directions. All kinds of fun stuff. So coxa. Then there is a little almost knee-like segment in between the coxa and the femur called the trochanter, but because of the angle of the legs and all types of stuff, we're not going to be able to see that today. The femur is the first big segment of the leg, so it's also the first big bone in our leg between our hip and our knee, right? The femur. On insects, it's the same way. We also have a tibia between our knee and our ankle. Insects are the same way. The tibia is the next large segment of the leg. After the femur, you get the tibia. Then you get all of the little tarsi. These are going to be little toe segments. If I was going to focus maybe up a little bit, I can focus on this middle leg here. You've got that tibia with two tibial spines at the end of it, and then you have 1, 2, 3, 4, 5 tarsal segments. So those are 5 little toe segments. Also, burying beetles have absolutely fabulous tarsal claws. They tend to have these really, really nice long claws, and there's a part of me, sometimes I see big tarsal claws and I think, wow, that male really needs to hold on to the female, something along those lines. But I kind of wonder in burying beetles if the tarsal claws are helpful for, one, digging, or if the tarsal segments are also helpful for, creating the ball. They need to be able to make their meatball. Okay. So the coxa here is like a rounded plateau. It's coming down at an angle. It's going to be like it's coming down like this. So it's going to be wider at the base and kind of narrow up here. And it's going to be kind of round and open on the top. Like this. So that's your coxa going forward. But then we're going to have the femur, and I want the femur to be moving forward. I might move it. I might do it in this direction though, just so that it doesn't interfere. I don't want it to interfere with the head too much, so I'm going to see if I can go right below the head. I also want to see if I can get a better view of this front leg here. I think the front leg I have a better view of on the other side. Look at all the hair on the tarsal segments. All right. So that's the front leg there. We can see the femur and the tibia pretty in focus, and then we'll refocus it for the tarsal segments. You can see it's nice and kind of round here. There's not a lot of specialty, looks like it's happening on this front leg, although I thought that there was. So why does it not look too fancy? Maybe the spines are just in the other. Yeah, because look at how cool that one is. Oh, there it is. Now I see it. Look at that. Okay, this is better. There we go. That's the tibia that we're looking for. So right there, you've got the femur. The femur was really smooth, so we're not going to worry too much about that. For the length of the femur, it's going to reach here, nice and smooth, coming around, connected to the bottom. Something along these lines. Just know that you're connecting it to the bottom of that coxa, but then erasing any portions of it that copy it. See? So you've got the coxa and the fibia. The femur is on top. And then the tibia is going to come backwards in this direction. Now the tibia looks like it is nice and narrow up on the top, and it's got that fabulous tibial spine. Spurs have joints, right? Spines are just pokey. And the spine is away from the body, so that would be on the right-hand side of the tibia. It would be like actually coming out directly towards the viewer. Alright, the tibia is going to be approximately the same length as the femur, so you can use that as a guide. Narrow on the base, but a little bit wider at the end. I like to imagine it kind of opening and closing, and that's going to give me my length here. I'm actually pretty happy with this. And then for the top one, it's got to kind of start narrow, and it gets a little bit wider, and then it cuts. And right here, where it gets a little bit wider, that's where the spine goes. And the spine is coming out towards the viewer. Okay. And then there are tarsal segments, and there are going to be 5 of them. Susan, Scott, Granny, what big claws you have, all the better to make meatballs for you, my dear. I think that this is a male. There is a tidbit of knowledge that's leaking back into my brain that I would like to share with you, but I'm not sure who I heard it from. I might have heard it from the tiger beetle guy and not the burying beetle guy. There's a family of beetles that on the front tibia, the males are going to have large lines of thick hair like this that looks just like this, and they use it during the mating process to kind of like brush on the females, I guess. The males are the only ones that have them, though. And so I know that that's a true statement, but I don't remember if who taught me that was the guy who I was talking about burying beetles with, or the guy who I was talking about tiger beetles with. Sad day. The more I think about it, the more I think that it was tiger beetles. But why not both? It's just, we can put it under that nature journaling category of it reminds me of. It reminds me of the brushes on the front legs of the male beetles. 1, 2, 3, 4 triangular segments and a raindrop segment with fairly long claws. 1, 2, 3, 4 raindrop claws. There we go. Alright, so now what we've got to do is kind of finish up this line here. I just want to make sure that the line on the bottom of the prothorax comes out at least above the edge of the compound eye, right? It's got to be up here, at least on the neck region. That can come up and finish up, and that gives us a prothorax. Now, in the very center of the pronotum up here on top, oh no, they don't. I thought they did. Nope, doesn't. One of the things that I like to do on the pronotum, though, is to kind of give it a double edge because of how defined the edge of the pronotum is. A lot of times I like to come back through and kind of give it a double line in here so you can see the edge. Cool. There's the scutellum. It's pretty giant. as scutellums go. In fact, it's that little triangle bit in between the elytra there. So for those of you who have not seen a scutellum before, it's right here, this triangle piece. All right. I've got my sketch here. I'm pretty happy with where the scutellum starts down here, but it kind of just ends at this flat line, and this is where the close elytron meets the elytron that is further away. And this triangle crosses both of them. So where I'm happy with this angle kind of coming up into the center, I not only want it coming up, but it needs to come back. But it's going to come back at a lot stronger of an angle because at this point it's like further away. It's a perspective situation. So I want it to come back to essentially where I had met the elytra to the pronotum here. And that right there is a scutellum. You tell 'em, scutellum. Sorry, it's been a long day. There's a cool shape that happens sometimes, but I want to see if that's due to the pin or if it's... I think it's due to the pin. Alright, so I'm just going to allow this elytron to kind of be very narrow and in the back. Just going to make sure that it starts right here where all of the corners start, where all of the edges are. I don't want it to go over top of this lip here, right? That lip has to be a little bit taller. Just keep it nice and narrow, nice and neat. And then I'm going to do the one on the inside. Make sure that where those elytra meet, we've got a nice straight line down the center of the back. That's actually, oops, that moved up a little bit. That's better. Pretty straight line free-handed. I'm actually pretty proud of that. Second time around. Now for the edge of this elytron here. So you might be noticing elytron is the singular form and elytra is plural. But so when I refer to the individual elytron as like the one that's further away or the one that is closer, elytron is singular. We say elytra a lot of times, most of the times, because elytra always come in pairs. It's kind of like saying pants. It always has an S. It's always pluralized. You don't go put on your pant. Alright. Now one of the things that I'm noticing about the elytra is that it has kind of an edge and then it curls over. So I like this one up here. You see how that's the one I want to follow first, way up here. And then we'll add this U bottom after we get it. So this is actually the top of the elytron here, and then this is actually like an edge. Okay. So I'm going to make sure that this is up a little bit higher than what I had originally done because we're doing that top edge here. I also want to, once I diverge from the mainland here, I want to kind of come up and then down and then up again. Yeah, kind of like that. Now, one of the things that you'll notice is kind of where the taller point of this is. That's also going to be right above the end of the thorax, because a lot of times the elytra has a little bit of an indent right here above the third pair of legs. And then what's really noticeable is that in between the third and the second pair of legs, there's this like U here, and it wasn't as prominent in my sketch, so I'm going to make this even it's just a little bit better of a U, not that much. Yeah, it just looks so straight. There we go. I found the center line. You know how if you press too hard on your paper and then you end up with like a line that your pencil wants to follow, and there. Okay. So we've got the top, and then it's just so aggressive now. Okay. And then we're going to add this U shape here, but it's not going to start way over here. It's going to be more, it's going to be closer to here. Here. No. Yes. Originally, I had imagined it as a straight line, but it is actually kind of hewed down just a little bit, and then it'll come all the way out here, and then it'll give you that little corner. Alright, this dark side here, the edge of the elytra, these are always going to be really dark, kind of black, just kind of shaded here. This particular burying beetle has that really beautiful orange stripe across the top of the elytra here, and then two kind of orangey spots along the back of the elytra. There we go. So that is looking good so far, I think. Perfect. Erase this where the orange is. Make sure we didn't get cool. Perfect. Alright, we've got the elytra figured out. So now we'll go ahead and look at the rest of the thoracic region. So that's going to be the meso and the metathorax. Meso being middle, meta being the end. And because we are looking at the bottom segments and not the top segments, what we are actually looking at, if you're looking for a word, is the mesosternum and the metasternum. That's what we're going to look at. Which is essentially just this large region underneath the elytra. So if I was going to point them out, I would say this right around here is the mesosternum, and then this from here to right around here, this region, that's the metasternum. I am actually personally pretty happy with the square that is happening here. So I'm just going to leave the square, and we're going to add the legs, and then I'll finish up the lines kind of behind the legs. So we're going to do the middle leg. keep in mind, because the middle leg is on the mesosternum, you can actually add a meso to any of your leg words. Mesocoxa, mesofemur, mesotibia, mesotarsi. Although normally they say tarsi on the middle leg. You could say mesotarsi though. So this is the middle leg. Now the middle leg is much easier to see all at once. It's easier to get a good. I just don't. I breathed too deeply and I blew it over. Don't breathe. Don't blow the specimen over. Look at those spines. Cool. All right, that's where we're. Ow! That's where we're gonna leave it for the middle legs here. Now the middle legs are connected way up here, very close to the front, even in front of that orange line. So if that gives you a good kind of place to compare it to, I would go in front of that orange barrier right around here. Now, the legs on this specimen are coming up and going back down. That's going to be a more natural kind of rested position for this burying beetle, but I didn't want to do that because I didn't want that leg to be in the way of the face. So we are going to make this beetle kind of standing up tall a little bit, which means that the middle and the hind legs are not going to be going up as high, so that I can get them all to match with this middle leg here. In fact, we're probably going to do something like this. Yeah. Where this is going to be the femur, and we're not even going to be able to see the coxa because of the way the femur is connected here. And the femur is going to be kind of wide at the base and follows out. So that would be a femur. And then the tibia is going to come down. It is narrow on the top, a little bit wider at the base. Yes, there are 2 tibial spines at the end here. And then we do have those 5 tarsal segments. And those 5 tarsal segments, let's see. I think they're primarily super pokey and triangular. Yeah, let's go zoom in on those. These are really fun. Not only do they have bright orange toe hair, but I'll show you. Let me see if I might be able to focus in on just one of them to show you what I mean. All right. Don't breathe. Right there, we can almost see it right around here. There's a dark line that comes out this way and a dark line that comes out that way. Those are little spines coming off of the tarsal segment. There's another one over here. And I believe that each one of these tarsal segments has their own little spines that look almost like little tibial spines. The tarsi have little spines on the ends of each of them. It's really cute. So the first one is really long in comparison to all the other ones. So you've got that first tarsal segment, and then 2, 3, and 4 are kind of short, but sharp. 2, 3, 4, and then I'm going to add the spines on the bottom, and then the raindrop with the claws. Middle leg. Now the hind leg is connected pretty far back. I want you to look at where the square is, the back of your thorax is on your drawing. That hind leg is coming out from all the way over here. So this is where your metacoxa. Oh, and once we get to the hind leg, we're no longer saying meso. Now we're at the meta leg. The metacoxa is built into the body, so you're not even really going to see the coxa at all, even if you do try and look. The femur here is going to be connected. I'm going to pull it out. I'm not going to bring it up over the elytra because we're still creating that kind of relaxed look. Or maybe it's more of like a pushing off and about to fly kind of look. That's what it looks like to me. Because these beetles do have membranous wings underneath they can fly with. That's how they get to the dead bodies, dead animals so quickly, is they're going to fly there. So they have to kind of push off the ground a little bit before they open their elytra, and that's what this reminds me of. All right. So I want this femur to be really wide at the base and narrow at the top, and at the very tip I have myself like a little inverted C shape here. That's where the tibia is going to fit in. Any of the lines that are inside of that femur we no longer need. Yeah. And then the tibia comes out nice and long, and it looks like, at least on the hind leg, the tibia appears to be longer than the femur. Just by a little bit. Got the spine. There's probably going to be two, actually. And then we have tarsal segments. Now, it's actually easier for me to just zoom to the other side, because the leg on the other side has its tarsal segments shown off beautifully. Decrease the light a little bit. We don't need it so glaring. Actually, where is my auto exposure back? There we go. All right, 5 segments. 1, 2, 3, 4, 5. Tarsal claws. Spines at the base of them. Don't need that. Don't need that. All right. Now we've got now the burying beetle has legs. All right. Now I'm going to finish up the rest of these lines, so I'm actually happy with just kind of drawing that one line that's left here, and then coming back and just making this slightly U-shaped. That's just going to give a little bit of shaping to the body, not perfectly straight is the goal. All right. Now all we need is an abdomen. From this perspective, I see 1, 2, 3, 4, 5 abdominal segments, but I want to flip this beetle over completely because sometimes segments are hidden, and I'm curious how many it has. 1, 2, 3, 4, 5. And do I have a side one tricking me? No, there are 5. 1, 2, 3, 1, 2, 3, 4, 5, 6. Nope, there are 6. Yeah, 1, 2, 3, 4, 5, 6. All right, there are 6 abdominal segments on this beetle here. But from a lateral perspective, I think that we're only going to be able to view 5 of them because one of them is really narrow and at the base of the legs. 1, 2, 3, 4, 5. Yeah. So there are 5 visible from our angle. But if you, like me, have a little bit of a spot here, you could always add that additional little segment that's not super incredibly visible, just like this. Boop. Now you've got one. That's your first segment. The second segment seems to end right about the end of this color spot, so I'm going to give myself some light lines so that I can see whereabouts I'm going. So I'm going there, going to right about at the end of the elytra. Kind of want this one just a little bit like there. Feels better to me. Okay, so we've got this one, we've got this one, and then we have 3 more. This is going to be 1, 2, 3. I need this one to be a little bit wider. 1, 2, 3. Yep, that looks about right to me. So now that I've got all of these nice kind of light lines all sorted out, I know right about where the segments are happening. We've got those spines going off along the bottom of the sternites here. And then each one of these abdominal segments looks like a little ledge. Also, something that I am seeing is that we do have a lateral line. It lines up pretty much with the edge of this elytra here. So let's go ahead and make sure I've got this all sorted. We've got this lateral line that starts here and is going to kind of come down this way, which means I think I might have to modify the angle of the abdomen. I might be making the abdomen a little bit more like, I need it to come up a little bit higher. All right, let's go ahead and see what happens. So alongside the bottom here, nice straight line comes through, goes back right there at the edge. Gonna add that little spine guy. This next one here along the top is not super visible because it is actually blocked by the elytra here. But what it does have is the bottom of the segment. It's just that also the bottom of this segment is going to end right behind this leg. So you're not even going to be able to see that spine. Alright, so the next one, which is going to be the first one fully visible here, I'm going to follow the top edge of the abdomen here to right about where I want to go. And then instead of coming straight down like I have this line going, I want to create almost like a very faint letter S, like a really pulled one, because it arches off to the left and arches off to the right. But both of those things happen before this lateral line here. So it's a very kind of slight curve, kind of like this, up to that lateral line. That lateral line goes out, and then it pokes, and then it follows its way back. Got like this cute little spine guy. They're fun. And then from here, coming down, it's got this little spine here, and then it comes in and goes down, and then right here along the bottom, you got that little spine guy. And then you're going to do that same thing again. You're just going to take this, you're going to step down a little bit, you're going to come down here, follow it to where we know that segment is going to go, but then this time it's more of a stretched C shape to that lateral line, kind of like so. That lateral line follows up and hits the other one. Now, for the bottom of this one, the bottom is also going to be slightly C-shaped. And follow and spine. More like that. And then this last one here is pretty much a triangle. So it's going to start as a little bit of a ledge here. We do want it to kind of come out straight for a minute and then kind of curve up just slightly. And then this piece comes back up to the lateral line, and then we're going to have another one that comes out and goes down. So now you've got almost like that little triangle. In between those parts is where the reproductive organs would be coming out. If we were to zoom in even closer to these segments, you would notice that those spines are not just along the bottom edge of each one of these segments, but they are rings of spines around every segment. So what you could do is take each one of these and add all of these little spines around each one of these segments. At least these ones. And one more. This one too. Yeah. All right. Burying beetle. I think he's pretty cute. I have never drawn a burying beetle with this positioning of his legs before. So that keeps my brain interested. Look at us. We have made it an entire 2 hours this week. So that's pretty exciting for me. Let's see. We got to talk about how they find mates. We got to talk about how they care for their young. We got to talk about their life cycles. When they get ready to pupate, they just crawl out of the crypt and make themselves a little chamber. They do have the ability to dig when they're adults, so they'll dig around through the substrate and they'll dig up to get out. So we got to talk about all of the behavior and stuff. That's nifty. We got to talk about taxonomy. That was really cool. Is there anything else we're missing? We got to deep dive into anatomy, which is great. I didn't add the segment between these two, but it would be closer to something like up here. Would be the end of the second segment, and then this whole thing is the third segment of the thorax. Oh, lately Susan's been tired early, but you made it to the end. Yay! I'm so happy you made it to the end. I'm getting a little tired at this point, but that's okay. I'm loving that. I think I'm gonna need to. I think something like that. Okay. Let's see. Burying beetles. Nicrophorus. Okay, so I am actually driving to Washington, D.C. this weekend. So, did you say what the adults eat? Do they eat the dead meat too, or something else? The burying beetle adults are also going to be eating the carrion and the dead animal. But they are also going to eat, like, if a fly goes and tries to lay eggs on the carcass, they're also going to eat, like, fly eggs, and they will eat maggots. So they will sometimes eat other insects, especially when it is to protect their families. Now, sometimes they will also, right, they're regurgitating their food, so not all of the meat that they chew up and essentially swallow, move into their crop, are they actually going to digest. And do the adults stick around all the way until pupation and guard the pupa? The pupa actually crawl out of the crypt. So the adults are going to stick around and protect all of the grubs, all of the larvae. And then the larvae, when they're preparing to pupate, are going to dig out away from the crypt and build themselves a little pupal chamber so that they can become a pupa away from their siblings. A lot of beetles do this because if you get messed with when you're in your pupa, there's nothing you can do about it. So not even beetles that are living together want to be near each other for something so dangerous, I guess. All right, I am driving to Washington, D.C. this weekend. I'm not sure how many of everybody knows, but I've been and will continue to travel with this expo called the World Oddities Expo. And it's happening in D.C. this weekend, so I'll be there with my tarantula handling her, teaching the public, selling some macro photography. I also do a stage performance on insect intercourse. So that's where I'm going to be this weekend in DC. Now, the schedule is out for next year, and next year I am going to be in 35 cities or something close to that. I may not be making it to all 35 because of different conventions and things, but yeah, that's a whole lot of them. So if you want to come and see me, that would be fabulous. I'm looking into doing maybe less of my virtual teaching next year just because I will be traveling so often, but I'm not going to drop the live stream because we've been doing this together for too long on Thursday nights at the same time for years and years, like 4 years I think at this point. So I can't imagine doing this live stream at any other time. Although there was a part of me that was pondering Wednesday. Let me know how you feel about it. All right. Super cool. Happy we got to talk about our burying beetle here today. I'm going to make sure I go ahead and put the date on the paper. It's October 24th. Next week. It's not October 24th. I'm writing October 23rd. Yes, I recognize it's after midnight, but it doesn't count. I made this on the Thursday. So, it's October 23rd, which means that next week we will be having a drawing. We will be able to draw next week on October 30th. Yay! And I'm going to have to pick a super awesome Halloween-y kind of bug. I'm not sure exactly what that's going to look like just yet, but drop by next week to discover it with me. If you all ever have insects that you really, really want to draw or look at, you can always suggest them to me at any point in any of the live streams. And if you suggest an insect for next week, then I will write it down and I will do my absolute best to work it in. That's the way I teach my students over in OutSchool. And I got to teach 3 classes. Today. I got to teach my kiddos about Atlas beetles because they requested Atlas beetles. And then we got to talk about sawflies with my older students and talk about the difference between a sawfly larva and a caterpillar, because they look very, very similar, but sawflies have more prolegs. It's really cute. So that's a little bit about what I am doing outside of my live stream. I thank you all for hanging out with me today. Make sure that you subscribe to the channel. I love all of you out there who are chit-chatting in the chat box, because I know that you've already subscribed, and that's a fabulous thing. So thank you, Susan and Bags and Life is Good, for being active participants today. I really super appreciate it. And I hope that all of you have a fabulous rest of your week, and stay buggy. Bye.